Okay. Good morning, or good afternoon, or good evening, depending on where you are attending from. And thank you all for making time to attend our webinar today. And today's webinar will be presented by Steve McKay, who is obviously, I mean, for some of you may know, and some of you may not know, he is our CEO, so to speak. But my name is Kumo, and I'm a course advisor for ECT, the Engineering College of Technology. And before we get started, I'd just like to turn your attention to the notifications and the sounds. If you could kindly just switch those off for now, so we can minimize any interruptions that may occur while the presentation is going on. And secondly, I would like to let you know that we do have a Q&A function. So that's right next to the chat box. So that's purely for you to put in your questions as we're going along. So Steve can answer them closer to the end of
Myself?
our webinar today.
Yeah.
And for this webinar, we will be having the copy of the slides as well as the recordings available to you. So what you will need to do is fill out a survey, which I'll give you the QR code to, as well as the link at the end of the presentation. And I cannot just stress the fact that it needs to be filled in within 2 days from today. And after that, it will expire. So that will just enable you to be able to receive the copy of the slides, the video recording, as well as the certificate of attendance. So with the certificate of attendance, that will be sent to your email within 4 business days from today. And with the copy of the slides and the video recording, that will be sent to you within 2 business days from today. So if you do not find it in your inbox, it will be in your junk or spam mail. And just for the conduct for today's webinar, if you can just follow my instructions to avoid any hassles so we can have a seamless presentation. And just to let you know a little bit about ECT. So ECT has now been around for a little over a year. We recently just started with our master's program, and that's going on as we speak. So ECT is an engineering specialist with industry-driven programs, and we offer recognized UK education. And that's all made possible by our lecturers and our instructors who are specialists in the field. And what sets us apart is our unique delivery model. And today's topic is applying AI for engineering productivity. And as I've mentioned, it will be presented by the also ever insightful Steve McKay. If you don't mind, you can take control and take it away.
Thanks so much, Kumo. I really appreciate that joining. I just need to get the take control. I think you just need to pass control to me, I think. Great, it's coming up. I think the other presenters have control. I think that's the problem.
Okay, let me just quickly make them attendees, 2 seconds.
Yep, I think that's the problem. Okay, hi everyone. I've got 120 slides here. Obviously, we're going to do this presentation in 45 minutes, 50 minutes. I'm not going to try and do everyone in 10 seconds. I'm actually going to do the key issues in the slides, but you will get the whole set of slides for your own use. And I'll just dwell on the key points and obviously contemplate those. So hang in there. We're just getting all the attendees joined in, and there's probably a lot more than we expected, but that's very great. That's fantastic. I've got a lot of questions to ask everyone with slides, and Kumo is just putting all the slides in now. So this is going to be focusing on engineering, And I've obviously got quite a few little topics I want to talk about. Obviously, why is this important to you? And then obviously discussion about AI, and then some of the issues with AI from an engineering point of view, and then some applications. So as I said, please forgive me. I won't be going through every slide. I'll just be going through the key ones. So hang in there. I'm just waiting to take control of the slides from Kumo, and we just got that set up. We
Can you
just got
please
quite a
just check if you can take control of the slides now?
still not yet, Kumo.
Okay,
Um,
let me try and let me stop sharing, and then you can share on your side. Let's
okay,
see.
thanks. Oh yeah, that'll be right. Yep. Uh, still no slides.
Are you not able to upload the slide on your side?
Um, no.
Okay, let me just put it
I
back.
had control. I had control earlier on, but
Yeah, let me just see if I can't put it back, and then let's see if you'll be able to take
that'd be
control
good.
now.
Thanks. Yeah, thanks. Forgive me, everyone. We just got a little Microsoft issue to deal with, but we will be on shortly.
They should have called it Microsoft Hard because
Micro hard. Yeah.
Micro Hard.
Maybe I'll log in again, Tony. I mean, Kumo.
It's just loading the presentation quickly. Let's
Ah,
just give
good.
it a few seconds.
Thanks. Thanks, everyone. Just hang in there. As I said, we're going to be doing a lot of materials, and I'm chewing up my time now. So just hang in there for a few seconds while we load up the slides,
Okay, there
and
we
away
go.
we go.
Just let me know if you can see it.
There we are. Brilliant. That's fantastic. Absolutely fantastic. So forgive me, everyone. We had a little issue with Microsoft. It's when people join, they get made as a presenter, which unfortunately is a technical problem, but we will overcome that. Okay, so what we're going to be doing is, if you look at the bottom, you'll see there's about 120 slides. Um, Kuma's already gone through the settings and obviously the common conducts. Obviously, please try and avoid any expletives or any unreasonable conduct. And this is for ECT. So really what I want to do and focus on this, thanks so much, Kumar. I'm all systems go here. If you can just make sure we're all recording happily. So really what we want to try and do in this is obviously look at AI from an engineering productivity point of view. And that is obviously going to be the critical thing. And I'm going to be obviously talking Steve Mackay. I'm the principal at ECT, Engineering College of Technology, based in Stevenage. Happy days. And obviously, I'm very passionate about engineering. And I've been presenting on this topic of AI for the last 3 years, 4 years, and probably learning more from you than you learn from me. But that's the great issue with teaching. And AI has come a long way over the last 3, 4 years. And there are significant opportunities for you, and there are significant problems as well. So obviously, I'm going to be focusing on that. Now, I want to get a little bit of a profile of you um, as the audience, um, just a little bit of an idea of who you are. I want to talk about why AI matters to you in engineering. Um, I want to talk about the essentials of AI and large language models, just a quick introduction. I'm not going to go through all the design issues there, much as I'd like to. We don't have the time. Some practical applications, risks, limitations, and safeguards, demonstration of AI applications, and then just a little roadmap of the way forward. So this is all going to be done in 45 minutes. So a little bit of a challenge there, but that's all the nature of the beast. So we there is a way of um, getting into the presentation from an AI point of view. I'm hopeful that you've already got an AI tool on board, but if you don't, here's an example of one you can use, Duck AI, on your computer or your phone. Very easy to use. So if you want to, you can use that. But we'll take it from there. I've got the chat going on the side, so I will come back to that. I won't be able to jump in all the time, but I'll try and get in every 5 or 10 minutes. So Duck AI is a very good tool you can use because it doesn't require any registration, and I've checked that it works fine. Please, obviously, don't put any real plant data or anything useful on it because it will be remembered. And obviously, don't put your personal details down either. We want to obviously do a few demonstrations, and I want to look at some practical applications. So we're not going to just sit around doing nothing. This is a 45-minute presentation, and it's from a 2-hour presentation, which I normally do. So I've condensed it quite sharply. But as I said, the slides will be there for you. So I just want to get a quick profile of you. I'm not going to ask you all the questions. If you can just give us the following question: which AI tool do you use? If you can just fill in the text box, there's a little text box that you have. Just give me a quick idea of your AI tool you're using. That'll be very useful. So just put that in the text box, like for example, Claude. Okay, yep, Claude. Copilot, ChatGPT, OpenAI. So I just want to get a bit of a view of who's doing what. Codex, yep, ChatGPT, Copilot, ChatGPT, Claude, DeepSeek, DeepSeek, okay, yep. Program scheduler, use Claude. Okay, so there's a significant jump in Claude usage from a year ago, and Gemini, okay, and not so much ChatGPT, which is interesting. So there's obviously a bit of a feverish move across to the others. Certainly, we're using Claude a lot with our programming applications. Copilot, ChatGPT. Okay, that's good. Excellent. So the next question is, I'm not going to ask all these questions. I suppose the next question is, what applications do you use AI for? So just give me a quick, just 1 or 2 words. I'm a biomedical engineer. Yep, that's good. So what are you using AI for at the moment? Just put down in the box. It gives everyone a bit of a view of what's going on. You can see we've got a very wide usage. It used to be only OpenAI ChatGPT, but now it's widened quite considerably. What are you using it for? Research? Yep. Okay. Substation design. That's really interesting, Danny. I'm going to make a note of that. Maybe, Danny, if you've got a moment, you can give us a rundown later on when I go to applications. I'll try and squeeze you in. Just a little chat there. Okay, we've got some really interesting ones here. Coding, engineering methodology, research and report writing. We've got process design. That's another one, Bhargavi. Yep, okay, that's a good one, Bhargavi. That's a good one. And substation design. I'm going to try and squeeze you guys in later on in the presentation because you're doing something really interesting. So Bhargavi and Danny Chu, if you could just give us, when I talk to you in about half an hour, maybe you could squeeze in a quick discussion about how you're doing things because you've got something unusual. Most of us are using it for research and summarizing, research and design formulas. Okay, that's great. Excellent. Okay, beautiful, 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 beautiful. And I suppose the next question I want to ask is, what challenges do you experience using AI? So can you tell me any challenges? Just put it in the box there, it's constructed bad code for me, or I've been doing 61508 programming and it's for safety design and it's messed up, or just give me some examples of any problems or hassles or irritations you've had. Just put it in the box. And that'll give us a good profile of who everyone is. And by the way, all these comments will be circulated with the presentation later, so you won't lose out. Okay, yeah, okay. First one, it can't draw. Yep, absolutely right. Yep, thank you very research instrumentation. Yep, can't draw. Not always anchoring on data gathering from secondary research. Thank you very much, Steenkamp. Brilliant. Wi-Fi troubleshooting. Oh, that's interesting. Okay, yep, okay. Not so good. Sometimes they give different results. Yep, that's true. Doesn't give clear circuits. Thank you very much. Accuracy of data. Brilliant, 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 brilliant. Thank you very much. Those are all valid things. Doesn't give clear circuits, accuracy of data, different results. Absolutely, absolutely. So you can see what I'm going to be driving at in this presentation. The engineer is absolutely critical. The engineering professional, critical. Unclear data. Okay, that's good. Inability to read PDF documents and complex spreadsheets. Yep. Okay, thank you very much. Okay, that's good. Okay, that's fantastic. Okay, so I'll come back to these later, but that's really good. So I suppose, obviously, why AI matters to you in engineering. Here's a little diagram I've constructed, very hard to read, I'm sure, but that will give you a bit of a view of all the different opportunities um, with AI. You can see it ranges. I've tried to summarize everything. I had to have a few battles getting this together in a reasonable format, but it eventually came right after about 10 attempts. But you can see it's a wide-ranging areas that you can use ChatGPT and Claude, Gemini, blah, blah, blah. So we're all under pressure, and obviously assets are aging, labor shortages, complexity is increasing. So we're hoping that AI will come to the rescue. And in this little presentation, I want to talk briefly about SCADA systems, PLC systems, and some of the little tricks and tweaks that we can do. And obviously, as you have pointed out to me, we can use AI to help with documentation, analysis, research, troubleshooting, etc. So the goal is not fewer engineers, it is better engineering decisions. In other words, doing more with less. And obviously, um, you will find as engineers or engineering professionals, whether you're technicians or engineers, you will move faster through routine analysis and communications. And we need experienced people. That is going to be one of my themes in this presentation. Experience is absolutely critical. And if you don't have that and you're going to use AI, you're looking for serious problems. Absolutely right. Okay. So very important to get that thing through. That's going to be one of my little threads through this presentation. Um, so why does it matter? I'm not going to go through every point here, but obviously adoption is accelerating and obviously the hype is accelerating. So we're getting a lot of misinformation. We work with data-driven systems. That's how we've always operated. Data, evidence. Show me the data, mate. AI boosts engineering productivity. Well, there's some numbers saying 20 to 40%, and there's some guys saying, and ladies saying, minus 30%. So what is true? Hopefully I can give a bit more, should we say, color to that. And obviously we're hoping that it reduces risks. But I can promise you now, if you think that AI is going to reduce risks, read this report on AI coding agents in industrial automation. It's a horror story. So I will come back to that later. And obviously, whether we like it or not, it's becoming a core engineering competency. And I would imagine employers are starting to say, hey, brother, sister, are you using it? Now, here's a little summary I did for electrical engineers some 6 months ago, and it's pretty true. You know, it can answer technical questions. And I want to come back to my good friend Danny Chu about substation design because I think it can help there. We've had a few complaints in the presentation here already that electrical circuits are not well designed with AI, so maybe we can talk about that later. And obviously, code interpreter, ladder logic. It can write to ladder logic, but I'm going to give you an example of ladder logic a bit later. Don't worry if you're not an expert in ladder logic. We won't expect you to write it, but I'll just talk about some of the issues there, which will come up with one of my applications. And obviously, simple English explanations. Sometimes that works, not always. And then obviously solutions to difficult problems. project management, timelines, budgeting, latest research, sometimes better than doing a Google search. You can get a better bit of information. And obviously, while you're doing some work, you'll be doing some job research on how to raise your salary. So that can all be done quite neatly. And then obviously, if you're collaborating and communicating with other professionals, it's a great tool. Although I would say that one of my mentors in AI, he actually said, I've been using AI to do all my emails because it does it very quickly, but I've stopped doing it because it's taken away my voice. And I find that really, really irritating. So the story is not always quite straightforward there. I won't worry about that. So the strengths, obviously, for engineers, there's a few little suggestions there. Again, I'm not going to worry about that. And as we discussed, and I'm going to use these a few examples here, you can obviously summarize alarm logs, maintenance histories, technical documents, drafting reports. In fact, drafting reports is quite an interesting one. I've been using in fact, I've tripled my productivity using a little dictating tool, which used to be rubbish. Now it does really well. Dictating 10 minutes without having to type it in. And I am a touch typist, but I use that dictating tool. And then I run it through a AI tool just to clean it up. And I say, look, I only want 3 paragraphs. Bingo, it comes up with something really good. So you can do that really neatly and very quickly. Finding patterns and failures, although I will come back to one failure, an alarm log later, which it comes up with, but it's not always the truth, as we discovered. And obviously, first drafts of document codes, diagrams, first drafts only. But if you expect AI to draw a clean diagram for you, you will be disappointed. You will be disappointed. It's not at that stage yet. Whether it will get to that stage, I am not convinced. Okay, so the essentials of AI, just to make sure we're all on the same page, you'll always hear about words such as AI, artificial intelligence, machine learning as a component of it, which I just visualize as a wonderful statistical package. And then, of course, deep learning in the middle here. So we can see that's the structure. And obviously with neural networks, we've got these as the basic forerunner of a deep learning using neural networks, where you've got inputs coming from this side and you've got a weighted output coming from that side there. So these are your weights, and you've got your inputs, and then you get an output, and you've got millions of these out there, and then you've got a function to actually activate the outputs or not. And then you also have a bias, that little animal there. I'm not going to worry too much about this. This is the old style presentation, but I would like to just point out one of the beautiful things, breakthroughs with large language models, is you have a prompt, your text is broken into tokens, and a token is a numerical representation of a word. It's not always a complete word, numerical representation. So a computer is working with numbers. It's not even working with words. It has no understanding of language, no matter what the pundits say. It's a bunch of words that you're dealing with, which are converted into numbers. So that's really important. And they all are in a space, hyperspace, a 300th dimensional space or more. And that is the magic. And by having your concepts, your words in that space, you can then manipulate them. But the other beautiful thing about it is that you have a context window, which allows you to set the memory of your prompter, your AI tool. And attention is also really important because you actually have some context coming in. So you have the breakthrough with the large language models is not, do you have a sentence here? You have every word in that sentence is contextualized by the other words in the sentence. That was one of the breakthroughs. It's called attention. And the sequence, the order in which they are, is also the word, the number, the code is also adjusted by the sequence. So when it's a first word or a fourth word, it actually has some value placed in it as well by the actual place it is in the sentence. So that's really important. But the contextualization of the words is where the breakthrough comes through. And this is really the important point to take home, is that it's contextualized, and that's the breakthrough, attention, but also it is a probabilistic output. So you have the pump tripped because, and the next word afterwards is the, very no-brainer that, and that's got a 34% chance of being there, an 18% chance of pressure, A, 13%, and flow, 7%, etc. So there's a probabilistic output, and that's really important as well. So if you're dealing with a safety issue, I've got caustic soda in a tank and I need 100% reliability, are you going to use a probabilistic tool to do the control? Unlikely, mate. So just bear in mind always that we're dealing with a probabilistic tool. And obviously, the other point to make is prompt clearly. Now, prompting isn't as probably critical as it was before, but it does help you. So prompt clearly, constrain the task. In other words, put limits around the question. And then also, and this is where your experience comes in, verify with your experience as to whether this is correct or not. And I always apply, much to everyone's chagrin, I always apply Robert De Niro's rule, which is Robert De Niro from Taxi. When there's any doubt, there is no doubt. I know everyone around me, if they hear that expression one more time, they'll smack me. But anyway, don't worry about that. So really, that's really important. So powerful language and pattern machines, engines, rapid drafting, summarizing, restructuring, and comparison of technical information, generating candidate checklists. So it's a good chum on the side. And the basic prompt formula, most of you have been through the prompt, so I'm not going to worry too much about that. But basically with a prompt, I've got a whole lot of slides here on prompting. I'm not going to worry about that too much. Let me just go back. There's our prompt formula here for ChatGPT, but it could be used for anything else. Really just give a requirement in a nice specific structure. And in coding, you can also use a very structured formula. Be detailed and specific, include all information. And the other point, which is often neglected, which I now do because I get irritated with what we call slop, I specify the desired length of the response. I want half a page. And that is really important. And then also you can also have a boundary which says, do not cover this. These are probably not as critical as they were before, but it's still worth doing if you can. And then the final point is never trust ChatGPT, Claude, anything else. So here's a few examples of the tools. Obviously, predictive maintenance, that's quite useful. Vibration, temperature data, find early anomalies, prioritize high-value assets. And obviously, the idea with these is pilot first. Check it out first before you believe in it. Maintenance planning, work orders, very useful. SCADA alarm rationalization, you've got a lot of alarms. I will show you an alarm shortly, which doesn't always come up with the right thing. PLC programming assistance, I'm going to come back to these in a tick and show some particular issues. Engineering design support, process optimization. That's why I wouldn't mind Bhargavi in due course giving us a bit of a discussion about his process design. Energy management, load profiles, asset management, digital twins, power system applications, renewables, machine drives, industrial safety. So I've got a few little examples here I just want to run through. In a tick. I just want to talk about some of the limitations before I look at a few examples. I've got a few examples I want to bring up, and then I want to ask you, those two gentlemen or ladies, what their uh, how they're using it. So if they can use the microphone, that'll be brilliant. So some of the limitations, obviously it lacks deep physics. It's not always accurate, cannot replace safety, and needs verification. So I've hammered this home quite a few times. I mean, I'll give you an example. We've just designed some really, I believe, cute, neat um, virtual labs, like real representations of tanks, valves, and we try to use AI to do the design of the graphics. Rubbish, absolute rubbish. So we went back to SolidWorks, did all the designs manually with a human, and we came up with something really good. And then we applied AI to that, and we came up with some really good stuff. But the actual physics wasn't that good. And that's one of the challenges. So if you're going to ask it to do a drawing or some very specialized design, you're probably going to be disappointed. If you ask it to do a wonderful sunset, as you all know, beautiful sunset graphic, yep, it will do that, no problems at all. But a good engineering design drawing, we're still a way away. Whether we get there, I'm not convinced. It's a probabilistic tool. Some of the risks, we're over relying on it, and I already see that happening with report writing. People are not checking their stuff they're writing, and they're often putting in gibberish or stuff which takes 4 pages of slop when you can do it in half a page. Faulty recommendations, we already had that suggested early on. Cybersecurity is a big problem with hacking, and obviously IP leakage. I would say, and I'm going out of kilter here. I'm going to make an observation that IP isn't as valuable as it was in the past, but certainly anything you put on your AI chatter with your company, it will be picked up by something. And they say, no, it's not. But honestly, I can tell you now, you do have leakage happening. So you've got to be extremely careful about what goes out. My philosophy is that IP isn't as valuable as it has been in the past, but it's still an issue if it's highly confidential information. Safe, and you may be following the rules, but other people in your company, are they following the rules? Big question. So these are all big questions one needs to answer. And then safe use framework is a bit of a framework here for how to go about it. I don't have the time to go through the whole methodology here, but obviously validate with calculations, check the standards, simulate, pilot first, don't go all in, and then document exactly what you're doing. Very important. And then obviously failure modes are, I mean, the list goes on from invented specifications, false references, that's a favorite one. It tries to check now, but again, check, check, check. Or even if it may come up with a reference which seems correct, go and check that it's actually a useful reference. Often it's gibberish. Um, the poor performance with the data is incomplete, messy. Uh, and often, if you're just giving it data without context, you have problems there. Um, and then, as I said, often standards incorrectly used, trips, procedures are missing. And the other problem is that engineers often don't write well, so they use ChatGPT or one of the Claudes to write, and it actually is too polished, and it's actually not focusing on the real issues. So these are real challenges that one has. So it's really important to use your experience as an engineer to actually pick that up, and to make sure that your junior staff are actually getting some of this experience into their heads. Because if they're not, they're going to have difficulty assessing things. So that's really, really important. And I'm going to come back to Raymond in a moment. I'll come back to those questions in a tick. Um, Junior staff skip calculations, drawing checks, and site reasoning. That's already happening. So it's really important to make sure your colleagues are not doing this. Learning pathways, and check and use AI to check and challenge juniors staff. People are inexperienced in a particular area, test them out, make sure it's in their head with the experience. So best workflow is draft, junior critique, senior review, and then field validation. Check it out in the field. And then obviously I've mentioned data privacy and security. That's a real big problem. Um, And as I said, a simple safe use framework is check where the source of the information comes from, any AI generated. And honestly, I have to, in 60% of the time, reject what I've been given as a recommendation because it's not quite right. So check where the information comes from, what assumptions has the model used, accept that, standards, find out which codes it's been using, verification, what calculation confirms it, and then obviously make sure you sign off with someone experienced. And I suppose the question for you is, if I want to ask you in your organization, which check is the weakest? Source, assumptions, standards, verification, accountability. Just put it in the text box. Okay, I've got a lot of discussion points here. I'm just going to quickly go through them, but what do you think in your organization are checks that are not being done properly? You don't need to disclose which organization you're with. I don't want to know that, but which check do you need to improve on, do you think? Just put there. Accountability, verification standards. Verification, yep, that's true. That's very often the case. Data verification, yeah, I'll check the data because often that's coming from something and it's not necessarily contextualized properly. Standards, and that's a very good point Raymond makes, standards. Now, I would tell you now quite categorically, I'm not convinced that when you're using, let's go back to substation with Danny. So the substation has a standard 61, what's it, 61450 or whatever it is, IEC 61850. That standard is not in the AI tools because it's copyrighted. So if you expect it to go and work against that standard, it doesn't exist in the AI mind. All that exists is all the commentary in the field, which can approximate to it, but it may not approximate to any changes or critical bits in that standard. So watch out for that because you will be disappointed. So verification, validation. Yep, that's true. Absolutely right. Thank you very much. Obviously, governance is really important with your tools. Define approved tools and privileged data. That's really important. Create use case categories, low risk drafting, medium risk decision support, high risk operational change. So give some guidance to your colleagues. And then work out some way, if you're using AI, for anything which is going to be high risk, for some way of checking, not just one person, maybe two or three people. And obviously, don't go full bore into any application. Try a pilot first and try and learn from that. And then update the rules frequently because AI is changing so fast. Make sure you're regularly updating. You don't just set up a set of rules and then you forget about it for the next 6 months because you will be disappointed. Now, I've got a few questions here for you to do. I've got a SCADA alarm log here. Now, I want to ask you, now we've got SCADA, which is obviously a supervisory control and data acquisition system. So it's looking at alarm logs and we can fit it into a chat GPT, for example, and say, hey, I want you to identify what the likely chain, what caused this here. So I want you to think about that there and obviously tell me what's happened here. So you've got discharge pressure low, P101 trip, tank 201 level low, process flow low, pump motor overload. What do you honestly think? Now look at the sequence there. So this has been analyzed by an AI model. And of course, the question for you is, what is the cause of the problem? So maybe just text in the box there, any suggestions? And tell me what you think. I've also written down something here now. Just text it in the box, guys and ladies. What do you think's happened there with this alarm sequence? This is a SCADA typical alarm sequence, and I'm using AI to explain what's happening. Yeah, okay, fantastic. Thanks, Raymond. Raymond's very quick and quite right. Now, the problem that we've got here, as Raymond says, that's exactly what ChatGPT will say. It'll say, hey, there's a low tank alarm and, we've got pump motor faulty. Now, that's a very interesting question Nawako mentions there, which may be the problem. So the first suggestion is insufficient fluid flow causes the motor to overheat and trip out. But the problem that we've got here, if you look at that sequence there, you'll see the tank level low is after uh, the pump is tripped. So it's possible that it reports late. That's possible as well. But it's possible that it's nothing to do with the tank, that the motor is tripped out. So what I'm pointing out here is that it's not just a straightforward analysis here. A AI application may not analyze this correctly. So you still need someone to come along and say what's happened and then actually go and look at the problem itself. Because you may find it's got nothing to do with the tank. The pump may have tripped out and that's it. So, the alarm order needs care. So the way I've analyzed it is the tank low alarm appears after the pump trip, so it may be a delayed alarm. So timestamps don't always prove causation, but those timestamps will be used by your AI tool to do the analysis. But it may not be correct because you need the experience of that bit of equipment, that part of your plant, to come up with the right analysis. So AI will fail here, or it won't necessarily guarantee a good solution. So what we're saying here is be very wary here. And as Nagwako points out, there could be things. Yeah, okay, absolutely right. So Zekeli says, Mr. Madlala says, there is a potential in misinterpretation there. So what I'm saying is the time sequence may cause your AI tool to come up with the wrong answer. So you have to understand your plant and probably look from bit experience to diagnose the problem. It's not always the issue. And we've got some really good gurus here. Ibrahim, thank you very much. Absolutely right. Absolutely right. So as Raymond says, SCADA may be able to help to investigate further. But what I'm saying is your SCADA tool comes up with a sequence in time, but it may confuse your AI tool in coming up with a diagnosis of the problem. And that's not going to go away. That's still there. Okay, AI-based PID tuning, I'm not going to worry about yet. Now, here's another one. We've got here direct online motor starter logic. This is a PLC bit of code which has been going on for years and years and years and years. Very straightforward. So you generate a 4-run DOL starter with start, stop, seal in, and overload trip. That's a classical problem we've had, forever. And, we've got all that, logic which you can put in and happy days, etc., etc. But the question is, will the AI tool come up with the right answer here? So it can do. It can do. And I would also say to you that the answers may be very obvious. But my question to you with this particular problem here, 4-run, start, stop, don't worry about that, don't worry about that. What do you think the AI tool would generally miss out on with this particular problem here? So I'm going to just talk about it rather than spit out what AI tool will come up with. What do you think it often still misses? Just text it in the box. Which you may not, your junior programmers doing this work says, go and do this, mate, for me, may not always get right. What do you think they may miss out here in writing this code, this bit of PLC logic with AI? Correct sequence. Yep, that's possible. Yep, no, you're quite right. Maybe a correct sequence. What interlocks will it leave out? Let's cut to the chase because time is tight, unfortunately. Okay, as time's very tight, I'll just add in here now. Typically, when it gets an instruction like that, it and your person that's doing the programming or giving the instructions to the AI tool to come with the programming may forget about things such as low-level protection, low suction pressure, discharge valve position. I've listed a whole lot here. Emergency stop status, guard switches, phase failure, motor temperature protection, blah, blah, blah. So there's a whole heap of real useful stuff which it doesn't put in. So those are the sort of things you as an experienced professional will know, but the AI tool may say, hey, brother, sister, I'm a bit confused here. Please help me. So what I'm saying is check, check, check. And I've got a list here. I've got about 20 here, which an experienced programmer. Oh yeah, thanks very much. Here's an example here. What have we got there? Okay, no for trip. Yep. Who's put this in here? Gracious me. Lovely. Thank you very much, Raymond. Brilliant. Raymond, have you got a microphone there? Can you talk?
If he can't, I can give him presenter rights and then.
Oh yeah, could you just give him presenter rights? Raymond, can you talk? Maybe
Okay,
not.
please hold on. I'm just quickly searching for him. 2 seconds.
Oh, don't worry. We've short of time, so. But look, Raymond, thank you very much for that. Don't worry, Kuma, it's fine. We're short of time, so I'll keep
Okay.
going. Ibrahim here has made a good point. The AI will probably generate a correct-looking four-run direct online motor starter program, but often miss site-specific engineering details. Thank you, Ibrahim. Absolutely right, which only you, as the experienced professional, know about. So really, that's the sort of thing you're going to have to check. Thank you very much, Ibrahim, for putting it in a nutshell. I'm going to steal your language in future. Thank you very much. I've got a whole lot of other examples here, but unfortunately, time is very tight. So here's a few questions I would like to suggest, design critique questions. Turn the AI answer into engineering review. What site data is missing? What standards must be checked? And local regulations, of course, will not be in the tool. We'll have no idea. And I've got a few case studies here, which I've left in the slides I've used in previous presentations. And local standards, local practice is often missing from the AI tool. And obviously, seawater corrosion intake, and these are all really important to bear in mind. So these are a few case studies I run on previous presentations, but these all require local understanding, and the AI tool will not have that. So really important. So some of the AI design pitfalls to manage are obviously hallucinated specs. Already had hallucinated, which means basically it makes up stuff. Missing local codes, and worse than local codes, if you live in the South Hemisphere, you'll find that a lot of the stuff is Northern Hemisphere or American European specific. So the Southern Hemisphere has been forgotten. So bear that in mind. Poor site data, bad outputs, climate and ESG misalignment. Yeah, okay, yeah, global north-south material bias. You need to be very aware that the liability still sits with the engineer. You can't get away from that. The IP on drawings is often a little bit murky, de-skilling of junior staff, and obviously it's a very helpful chum, but it's not an autonomous designer. It cannot design autonomously. Always make sure you aggressively look at what it's doing. So here's a few suggestions. Got a few comments here. Let me just have a look at them. Oh yeah, okay, low data. for training, especially in engineering. Yep, absolutely right. Yep, that's true. If you're looking for very good quality, uh, you've been told that you can write a course on an engineering topic, you will be very disappointed. It'll come up with a good sort of overlay and some good suggestions. But if you want the nitty gritty, hard hitting, useful experience stuff, no, it's not there, not always there, or it may be faulty. So watch out for that. Here's a few suggestions for 5 practical initiatives for your company. Um, AI assisted technical reporting, meeting summaries, which a lot of you are doing, SCADA alarm clustering, but obviously look at your particular plant, work order, troubleshooting, checklist drafting, PLC control logic documentation, and engineering design. Now, I want to ask you now, which type of PLC is it forbidden? Is it forbidden to use AI? Please text it in the box. Yeah, thanks, Ibrahim. Thank you very much. Oh, yeah, no, thank you. You are a guru, Ibrahim. I think you need to present this for me. You know this better than I do. Thank you very much, Ibrahim. You are very succinct and you're probably a classical scholar in English literature or something. You're very good with your words. Can anyone tell me what do you not do or not trust with PLC coding under any circumstances? In fact, it's illegal. What sort of code is it not possible to do control with using AI? Yeah, absolutely. That's really important. Safety codes, sorry, mate, 61508. Are you familiar with 61508? 61511, SIS, all these magic words. You have to make sure that that is human orientated, originated from a real person who's experienced. So don't think you can short circuit that. You'll be gravely disappointed. It's not possible at all. Here's a bit of a roadmap to run, 30, 60, 90-day roadmap, and obviously a few suggestions here, which may be worth looking at in the future. I'm not going to go through that. Here's a few suggestions for engineers tomorrow, and I don't mean engineers with a PhD or a chartered or professional engineer, anyone who's technician, technologist. Here's a few suggestions of working with AI. I use it as a little chum to ask questions. I'm not always overwhelmed with happiness with the results, but it's a useful colleague, a low-level colleague. And then obviously make sure that you keep skilling yourself up with AI, very important. Just small little tasks all the time using AI. It's a good tool to use. And then here's a few suggestions on one AI pilot that is useful, low risk, easy to verify to make sure that you're not making a disaster. And obviously identify the owner of the data, the output, and the safety checks. And obviously define what success is. Is it time saved, false reduced, downtime? In other words, put in the metrics. If you don't do that, you're going to be unhappy or you'll get complaints. And there's a little suggestion there how to test it. So really, the key takeaways, and I'm sorry to overshoot time here, Kuma, I've obviously overshot a little bit, but
No worries.
sorry, I'm a bit, it's too much to talk about in too little time. It's a good productivity tool, but it's not a substitute for engineering accountability, as I hope I've demonstrated it. Really start with some real operational pain. Try and apply it to something really useful, not just fashionable. Use AI for drafts, patterns, alternatives, but verify everything. As everyone here has most emphatically indicated, they do not trust AI, and you should be in the same boat. Make sure you check. And obviously, use it with engineering judgment at all times. So there's no free lunch. I suppose that's what you learn all the time. There's no free lunch. And then every day I get people coming to me, or every few days, hey, Steve, I've got a really great AI. I'm going to make $1 billion. I've got a business idea with AI. I've been an engineer for 15, 20 years in this particular area, and I've got this great idea. Well, I would just say to you, really, is that going to make a lot of money? Just when I put in these slides here, my suggestion is you can do very well, but what you've got to do with AI is don't just create another bot. Hello, I'm answering queries or something. Try and harness your innate skills as an engineering professional. I'm a guru on um, conveyor belt slippage or conveyor belt design or uh, maintenance of gearboxes or something like that, and then take AI and apply it to that specific scenario. Then you may have some outcome. But if you're going to just create a general tool, you're not going to be very happy. You'll be wasting your time. Hey, Steve. Okay, Ibrahim. Okay, as a powerful but can't replace engineering judgment. Now, thank you very much. Ibrahim, you're the expert one. Ibrahim's got some beautiful comments here. Please look at them afterwards and hire him. I'm not promoting your services, Ibrahim. Don't worry. I'm sure you're busy as it is. So don't start with a general AI product. Try and use something. Try and use your expertise, which you built up over many decades, and crystallize that into AI. Then you're laughing all the way. But if it's just going to be a general chatbot answering queries, probably not. And I had some guy the other day who's a lifting specialist, an absolute guru on lifting. And he said, look, I'm just going to get AI to identify security risks in our plant. And I said, hey, security? No, it's not going to be happy. There's a billion other solutions already out there written by someone in Ohio or West Waziristan. And unfortunately, they've already done that. But your expertise as an engineer in lifting equipment, I'm sure there's a very good AI application waiting to be developed and sold all over the world. Anyway, so just a few final comments here before I bolt. The design pitfalls to manage, hallucinated, missing local codes, and I've run through this already, but just again emphasize, diagrams are still problematic, as someone pointed out, electrical circuits, waste of time, de-skilling of junior staff, the liability still sits with you. You need to be experienced. And then obviously poor site data. So if you've got poor site data, you're going to have bad outputs. And I always remember being very disappointed writing Python code. When I used to write Python code, I was so exhilarated with Python code. And then my programming mentor said, mate, the coding is actually probably a small part of the story. Where you have got a huge weakness, Steve, is you need to go and clean the data and make sure you've got good data. You've got crap. Sorry, excuse me. Sorry, I didn't say that. You've got rubbish data. Okay, so you need to clean that up first before you can process it. And as we've learned for years and years, garbage in, garbage out. Okay, so a final wrap up. Sorry to overshoot time here, but I'm almost finished. Last slide. AI will not replace experienced engineers. I'm not sure if a probabilistic tool ever will. We're told they will, but I'm not sure. I don't think so. At the moment, it won't. Stay aggressively curious, critical, and focused on practical engineering impact. Use brutal experience always. And build your capabilities in data. Python now, great. Python, use your coding tool, Claude, to write the Python, but check it. And then obviously verify your outputs and then keep experimenting with AI. You will never be disappointed. And use it as a junior chum. Use it for drafts, but you have to check everything. And please start with some projects. Don't hold back. Try something. And with defined metrics. As I said, the alarm cleanup is a good one, although I'm a bit despondent when it actually made a mistake with the diagnosis. I should have had a clearer understanding of the plant, which I didn't do. Problem. And with PLC generation, good for general code, but SIS, safety instrumentation systems, no go. Okay, thank you very, very much, one and all. Really appreciate you all attending this. I'm doing this presentation over 2 hours, and I will be taking all your wonderful input to come up with something, especially these lovely people that have taught me so much on this presentation. So thank you very, very much. I'm just going to say thank you here, Ibrahim, and all these other wonderful people here, Heritier, Raymond. Thank you so much for your commentary here. Brilliant. So may I pass it back to my good colleague, um, Kuma, who will do the clearing, the closing down. This is all recorded. Send me any comments you may have. I'll just write my email. If you have any comments, I'll just quickly write my email, Kuma. Just give me 1 second.
Sure, no worries.
Just if you want to write anything to me, please don't send me any requests for my bank details. EIT.edu. And please tell everyone about Engineering College of Technology in Stevenage. We're very keen to run training courses, do presentations on your site. So if you've got anywhere in England, you want me to come and present this, I'm there. England, Scotland, I'll come onto your site, do the presentation. Please let everyone know I'm there. I'm your man, mate. Okay, sorry, Kuma, back to you. Thank you very much. Thanks,
Thank you so
everyone.
much, Steve. That
Cheers.
that was really insightful. I was gonna cut you short if it wasn't as interesting as it was. So thank you
Thank
all
you.
for attending today's webinar. I'm sure there's a few things that you might have learned, and that's all thanks to Steve. So I just want to let you know about ECT's upcoming programs. So for September, we've got two of our bachelors starting, which is the Bachelor in Industrial Automation. And then we also have our Bachelor in Electrical Engineering. So for October, that will be our intake for our master's programs for power system analysis and renewable integration. And the other masters that we are offering is the Master of Science in Industrial Automation and Instrumentation Control. So you can always go to our site and make an inquiry if you want to know a little bit more about that. And 9 out of 10 chances I'll probably reach out to you and discuss that, because I am, as I've mentioned, the course advisor for ECT. And lastly, we are currently having a promotion for our professional certificates of competency. These are basically our short courses, which are run for 3 months, and they're for upskilling and professional development. And we are running a promotion where you can save money on that, because normally they run at around £933, which it's offered through EIT, which is our affiliate. I will be sharing that information shortly with the link. Thanks for asking. But yes, so currently we are running a promotion, and the promotion will save you some money. And let me just actually put that in the chat while I still have you here. And then you can always just reach out to inquire more, but I will always be happy to assist in that regard. I have just put it in the chat. So if you can enroll before the 30th of November this year, that will make you eligible for that promotion. So it will be running for £600, which is quite a bargain. And lastly, I would like to let you know about our certificate of attendance that will basically ensure that you have this information. So the link is there and the QR code. So if you do have your phones, you can take the snap of the QR code. Alternatively, here is the link that I've put in the chat, and you can always go and fill that out. Please ensure that you do fill it in, because that's how we will know to actually send you the information. The slides will be sent to you, as well as the video recording, within 2 business days from today, and the certificate of attendance will be sent to you within 4 days from today. And yeah, I guess that's it for the day. And
Kuma, can I just ask one question? Those the chat on the presentation, we get that as well, don't we? I
the
just want to read
chat,
through it.
yes, we do get it, but it
Okay.
won't be available to the attendees. But I'm pretty
Okay.
sure if
Okay,
that's
I may just pull it out. There's some really good comments here. I'll pull it out and maybe we can put it on our website so people can download it if they want. Uh,
okay, sure,
I'll
we
uh,
can do that.
I'll pull it off. If you can get it to me, if you can just paste it to me, I'll clean it up and put it out for
Okay,
everyone to access because it could be
sure.
quite useful. So we'll let you know. There's a chat here. There's some really good comments from people. I haven't had time to go through them all, unfortunately, but I will make that available to everyone. Thank you very much. Thanks very much, Kuma, for hosting this session and fixing up some of the what do you call it? Micro hard
Micro hard.
technical bugs.
Thank you all for
Okay.
attending
Thanks, Aaron.
and
Thanks so
have
much,
an
everyone.
amazing day.
Cheers.
Take care.
Thanks so much. Cheers. Bye. Bye. Good
Okay,
night.
bye.
Bye. Bye. What? Oh, it's too late.